All right, we're going to do a few selected problems from section 6.3, and this is for the homework after the lecture in which we discussed permutations and permutations only. That homework is problems 1 through 10 of section 6.3. The thing I want to point out initially is the formula that you may recall, PNR, and that is a formula that gives us our permutation. So this is P n r, and that equals n factorial over, oops, I put a little slash here, over n minus r factorial. And so if I have to choose p of 5, 1, that would equal 5. And that's basically saying how many ways can I permute one object if there are 5 objects. So let's see what would happen if I had to permute using this new formula I just created, P5, 2, and that would equal 20. Now why does that work that way? Again, from the lecture, we recall that I have 5 objects to choose from at first, and then I have 4 objects to choose from, and I'm getting 5 times 4. And so I'm going to get rid of this. I'm going to leave that formula up there to begin with. We'll do a few of these. Let's do problem 3 to start. And in problem 3, we're given the letters A, B, C, D, E, F, G. That's 7 letters. But we're asked how many permutations of those end with the letter A. So in this case, we're going to actually have to permute the 6 letters other than A, and then the A will be at the end. So this is going to be permute all 6 from 6. So I'm going to use my function first. I'll just see what the answer is, 6, 6, and that is 720. Now, how did we get that? Let's do 6 factorial over 6 minus 6 factorial. And what is 0 factorial again? That is 1. We'll just do that here real quick. 0 factorial equals 1. So what we had was 6 factorial, which is 720, over 0 factorial, which is 1. 720 over 1 is 720. So that's how we do that. We'll put a little note over here that says, in this problem, there are 7 letters. We fix the 7th letter as A and permute the remaining 6 letters. Okay, so let's go. Let's do problem 4. Problem 4. In problem 4, what we have is we have numbers 1, 2, 3, 4, 5, and we're only doing permutations for this homework, so we only have to do part A, and that is all the 3 permutations. We're supposed to list all these. Let's first see how many they are. List all the 3 this is going to be fun, isn't it? Permutations of 1, 2, 3, 4, 5. Okay. Let's just see how many we're going to be listing. This is going to be P. There are 5 letters. We're permuting 3. 5, 3. I'll get there. So, 60. Oh my goodness. Who signed this? All right, let's see what we got. Control T. And we're going to make ourselves a big old thing here. 1, 2, 3. 1, 2, 4. 1, 2, 5. 1, 3, 4. 1, 3, 5. 1, 4, 5. And those are all the ones that start with 1, I think. And that was how many of them? 5. So only I have 12 more of these rows to go. Let's do 2, 1, 3, 2, 1, 4, 2, 1, 5, 2, 3, 4, 2, 3, 5, 2, 4, 5. Okay. And now let's see, 3, 1, 2, 3, 1, 4, 3, 1, 5, 3, 2, 4, 3, 2, 5, 3, 4, 5. And that's, so far we've got 15. I only have to do a bunch more, and since this video is going to be long enough as it is, I think you get the idea of what we're after. And you just fill the rest in to do that problem. The main purpose of this is so you get kind of a feel. Tedious, I know, isn't it? All right, so now, in order to find the value, let's do number 7. Problem 7. Oops. Problem 7. And this is, man, this is going to be, couldn't be more straightforward. It says, find the number of 5 permutations of a set with 9 elements. And so that is simply going to be 9 elements over 9 minus 5. Let's see. Make sure I'm reading this right. Yep, 5 factorial equals, wow, that's a lot. Let's put this into a regular number. That's 15,120. Let's see if our formula gives us the same thing. P 9, 5 equals. Same answer. We'll go ahead and turn that into a decimal number. Okay, well, looking good so far. Let's see here. Now let's do number 9. It's very similar to number 8. Problem 9. Typing. You guys should all be thankful that I'm typing this in MathCAD instead of doing this by hand with my mouse or something. How many possibilities are there for win, place, and show in a 12-horse race? So, there are 12 horses. We permute the first 3. So this is simply going to be 12 factorial over 12 minus 9 factorial. That equals a lot. That's going to equal 12 times, let's just do this, 12 times 11 times 10, see if we get the same answer. Ooh, I think I made a mistake here. Let's make that a 3. That's a lot better. All right. See, the mistake I made was I went ahead and did the math in my head and put 12 minus 9 there. All right, so we have, let's do our formula over here. P 12, 3 equals same answer. Okay. Finally, number 10. 6 different candidates for governor of a state. How many different orders of the names can be printed on a ballot? Well, for problem 10, what we have are, we're going to permute all 6. Permute all 6 names from 6 available. That is going to be 6 factorial over 6 minus 6 factorial, and that's going to be 720. We'll try that again with the little formula I made up above, and 720. One thing I hope you get from this is that if you go open up MathCAD, you can actually set yourself up some pretty handy functions, and these things can be very helpful with getting the right answers on these homeworks. And if you go to the effort to write the functions and get them working, then generally you have to understand the math well enough for that to work. Anyway, that's all for now. That's the problem set 6.3 after the lecture on permutations.